So this next section, we're going to look at the relationship between circles and angles that are formed within those circles or on the circles, things like that. See how we can use arcs and angles together. Okay, which shouldn't be too hard since we measure both of them in degrees. So let's just get a little vocab out of the way. A central angle we've talked about before, but a formal definition would be an angle whose vertex is at the center of the circle. Okay, and as we said earlier, this the measure of the central angle is equal to the measure of its enclosed arc or encompassed. Okay, so if I've got a central angle here, that looks like 50 degrees, okay? That means this arc that it's trapping is also 50 degrees. An inscribed angle, okay, is an angle whose vertex is on the circle. Okay, so that'd be like this. Okay, this would be an inscribed angle. And an inscribed angle equals half the intercepted arc. Okay, so if this is 50 degrees, this would be a 25-degree inscribed angle. Okay, so you can use that. So if you know the inscribed angle, you can find the arc. If you know the arc, you can find the inscribed angle or the central angle. If we have angles that are formed by a tangent and a chord, okay, so I've got a tangent line here, and it's meeting this chord at the point of tangency, and it creates two angles when it does that, 1 and 2. Now 1 and 2 are supplementary because together they make the straight line. Okay, so that means together they're 180 degrees. If I look at NM and NLM, together they make the whole circle, so they're going to add up to 360 degrees. Okay, well, if these two angles make 180 degrees and the two arcs make 360 degrees, what we get is there's a 1 to 2 ratio, okay, a 2 to 1 ratio between the arc and the angle. So that means that the measure of angle 1 is half the measure of arc NM. And the measure of angle 2 would equal 1/2 the measure of arc NLM. Okay, so if I just know the measure of this arc, I can take half of that, and that'll be the measure of angle 1. If I can get the measure of this, take half of that, that's the measure of angle 2. All right, let's look at angles formed by two chords. So I've got two chords here, they're meeting, and they make these 4 angles. Let's focus on angle 1. Angle 1 is going to be half again, okay? So you're going to kind of see this half comes up all the time. Just because there's 360 degrees in a circle and lines only have 180. So it's going to be half the sum of the two arcs that the chords are meeting. So angle 1 is formed by these two chords, and those two chords, if I look on the one side, also intercept these two arcs. So if I add those two arcs together, EH plus FG, okay, and take half of that, that'll be the measure of angle 1. We could do angle 2 here. measure of angle 2 would be half the sum of GH and FE. Okay, so it's kind of the vertical angles, the two arcs that would kind of correspond to those. You add them up, divide by 2. Okay, so to get angle 2, I'd add this one and this one. All right, if you have any combination of a tangent and a secant, so let's see what that would look like. We could have two secants. They're coming and meeting like this. Let's extend them here. So they're actually secants. You could have one tangent that's intercepting a secant. Or, of course, you could have two tangents that are coming and meeting. Regardless of which of these situations you have, the formula is the same. Okay, so we'll just call this angle 1, angle 2, angle 3. So let's put some letters on here too. A, B, C, D, and then we'll do P, Q, R, and we'll do N, L, M. All right, so the main idea here is we're gonna do the opposite of what we did for our chords. Okay, these were inside angles. Here we have outside angles. So these we added the 2 and took half. Down here we're going to subtract the 2. So we're going to take the big one here. So the measure of angle 1 equals half of arc AB minus arc CD. Okay, so I take this, subtract this, divide it by 2, and that's angle 1. Similar here, I'm going to take PR minus RQ, and then I'm going to take half of that, and that will be the measure of angle 2. Angle 3, I'm going to take NLM minus NM. Okay, so big minus little, divide by 2. Okay, so let's look at some examples. So examples, I've got an inscribed angle here, okay? And I know that this inscribed angle should be half as much as the arc that intercepts. So that means that 2x plus 6, okay, there's two ways to do this. I could say half of the arc equals the inscribed angle, or I could say the arc equals twice as much as the angle. Either one's going to get you the same answer, okay? So if we just subtract 6, I get 2x equals 94, so x would be 47. Okay, all right, let's look here. Let's find angle 1 first. So angle 1, since that's the intersection of a secant and a tangent, I know that it's going to be half of the big arc, 160 degrees, minus the little arc, 70. So it's half of 90, which which is 45 degrees. Okay, angle 2 here. Okay, let's look at angle 2. Angle 2 is an inscribed angle. All right, so it's going to be half of 70. So measure of angle 2 equals 35. For 3 and 4, that's the intersection of a tangent and a chord. So angle 3 should be half of the arc that's intercepted here, okay, between where it meets and where the top of the chord is. So that's 130 plus 70, that's 200. Half of that is 100. So angle 3 is 100 degrees. I already know angle 4 is going to be 80 because it's supplementary with angle 3. But we could also find it using half of this arc. Half of 160 is 80. The last one is we've got two chords meeting. Angle 1 is going to be the same as angle 3, which is half of 136 plus 91. 136 and 91 is 227. Half of that would be 113.5. So that's what angle 1 and angle 3 are. Angle 2 is going to be the same as the measure of angle 4, which should be, okay, we could do whatever supplementary with this, but let's do the new way. Half of 29 plus 104. Okay, 104 and 29. So that's half of 133, which is 66.5. Okay, and these do in fact add up to 180. Okay, so that's how we can use arcs to find angles or angles to find arcs.